we're doing the last section of chapter 10. Yay! Chapter 10's over. We're doing the last section of chapter 10. It's on binomial theorem, which can be like a really long problem. So we're only going to do 3 of them. Yay! Okay, so it's on pages 401 and 402. I also have the theorem written up here. Remember, a binomial is something that is 2 terms joined together with either a plus or a minus sign. So for example, x plus 3 is a binomial. 2x minus y is a binomial. So that's what we're doing, is binomial theorem, okay? And the reason that this is with the counting stuff that we did yesterday is because if you look at your formula, this part right here is our combination that we learned how to do yesterday. Now, remember, a lot of times they can go ahead and they can replace that part, that section there. Remember, means n factorial over r factorial times n minus r factorial. And remember, those little exclamation points, remember, are read as factorial, and they mean you keep multiplying down till you get to 1. So if it was 8, it would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so that's what that part is. Now the basic formula though, they usually just write it with this, because if you do have the scientific calculator, it's got the little button that you can use for the combination, so you don't have to write all this mess out. Okay, which is going to be really handy when we go to expand the binomials using the binomial theorem, which is what it's wanting us to do on these first 2 problems that we're doing today. Okay, so the first 2 problems that we're doing today are here on page 401, where it says expand the binomial. Okay, so we're going to use this binomial theorem up here to expand each one of these. And like I said, the thing is, these problems can get to be really long, which is why we're only doing a few of them, okay? So hopefully everybody's on page 401, and you found number 1.
Or 91.
And we're ready to get started with number 1, okay? Now, when we go to plug it into the formula, you'll notice, okay, in our formula up here, it has a plus b to the n power. So that means with the problem that we have, x is our a, so everywhere that there's an a in the formula, we'll replace it with x. Y would be the b, so everywhere that there's a b in the formula, we'll replace it with y. And then R3 is the n, so everywhere that we have n in the formula, we'll replace it with 3. Okay? Now, when we go to start doing the expansion, remember this symbol right here is called sigma. It's sigma notation. We used it when we did our series, when we did our arithmetic series and geometric series. It means the sum of the terms added together. So we're going to do the sum of all these terms added together. So remember, the number at the bottom tells you where you're starting. The number at the top tells where you're ending. Okay, so when we go to expand this, the first one is going to be when r is 0 and n is 3. The second one would be when r is
1
and n is 3. The third one will be when r is 2 and n is 3. And then the fourth one will be when r is 3 and n is 3. Because it has to go from 0 up to whatever n was, which in this case was 3. Okay? It has to go from 0 up to 3. Okay? It has to go from 0 up to 3. So when we go to do this, or just our basic formula, when I'm plugging it in, I will have the sum, again, from 0 to 3 of the combination. And you can write it 2 different ways. If you all, okay, I've got everybody there. Well, I've got everybody who bothered to log into class. Who has an actual scientific calculator that has where they can do the combination on there? Okay, I know Micah does. Aurelie, does your thing have the scientific, the little combination thing on there? Yes? Jazaria, do you have something that has the combination button on there? No? Yaneli? No? Okay. So, when we go to plug it in then, instead of using this, we'll have to actually write it like this, because we'll have to work it out. So my number on the top is 3 for my n. Then down here is still going to just be r factorial because I have to go from 0 up to 3. And then 3 minus r factorial. So that's my first part, okay? And then I'm going to have that times a, which was what? X, to the n, which was 3 minus r, and then b, which was the y, to the r. Okay, so I still left r's in there because I'm going to have to do this, remember, 4 different times. Because I have to do it when r is 0, I have to do it when r is 1, I have to do it when r is 2, and I have to do it when r is 3, because it goes from 0 up to the end, so 0 to 3 in this instance for number 1. Again, this is why we're only doing a few of these. Okay? Everybody get that? Yes? No?
Yeah.
Okay, so when we go to do this, I'm going to scoot over this way a little bit. So I got some room because I told you it's no. Okay, so my first one is going from 0 is when r is 0, right?
Yeah.
So I'm going to have 3 factorial over 0 factorial times 3 minus 0 factorial. And then that's times x to the 3 minus 0 and y to the 0. Everywhere that there was an r in this, I put 0. Okay, let me scoot you up closer. Everybody see? Get you up close and personal. Okay, everywhere that there was an r, I put 0. Okay, that's the first one. Then that's going to be plus, and then you do it again, but everywhere that I put 0, this time I'm going to put 1. So I'll have 3 factorial over 1 factorial, 3 minus 1 factorial, x to the 3 minus 1, y to the 1. We did it where r was 0. We did it where r is 1. Now we have to do it where r is 2. Remember, we keep going. We have to go from 0 up to 3. So now we do it with r is 2. So I have 3 factorial over 2 factorial, 3 minus 2 factorial, x to the 3 minus 2, y to the 2. Okay. I do it one more time because I've got to do it now with a 3 plus 3 factorial over 3 factorial, 3 minus 3 factorial, x to the 3 minus 3, y to the 3. Okay, that looks good and confusing, right? Yeah? I mean, to me, it looks confusing. It's got a lot of stuff in there. It's got a lot of stuff, so we're taking these slow. We're only doing a few of them. All right? Now, after you get all that written out, I want to make sure I didn't leave anything off. Okay, it looks like I did pretty good. All right. So, first of all, excuse me. First of all, if you paid any attention to stuff yesterday, does anybody know what 0 factorial is actually equal to? Do it on your calculator, Micah. Put 0 and then the little exclamation point.
1.
1. 0 factorial is equal to 1. Just like anything to the 0 exponent is equal to 1. It's the same kind of concept. Sorry, my hair was like all falling down and getting on my nerves. All right, so, okay. I want to chop it off, but nobody's open. All right, so we got this. So anywhere I have 0 factorial, it's going to be 1. So 0 factorial here is 1. 3 minus 0 is what?
3.
3. So basically, I got 3 factorial over 3 factorial, so that's going to equal
1.
1. Anything over itself equals 1. Do we write 1 in front of variables?
No.
No, we usually don't put the coefficient of 1 in front of a variable. So that part's 1, we're good with that. 3 minus 0 is 3. And again, anything to the 0 power, I just said a moment ago, was
1.
1. So do we need that?
No.
So my first term, all this stuff right here, is equal to just x to the third. Okay?
Wow.
All of that first part was just x to the third. Now we're doing this one. Okay? 3 minus 1 is
2.
2. So I've got 2 factorial and 1 factorial. Again, 1 factorial is still going to be what? Do it on your little handy dandy calculator.
1.
1, right? Okay, so 0 factorial equals 1, but 1 factorial also equals 1. Okay, so this is 1. Here, this is 2 times 1. 2 times 1 is what?
2.
2. I nailed it. All right, we're on page 401, and we're doing number 1. It's a big, long problem, so we haven't got real far yet. All right, so on here, remember what we did the other day? 3 factorial and 2 factorial, the 2 and the 1 will cancel out, so I would just be left with the what?
3.
The 3. So I would have a 3. And then here, 3 minus 1 is a 2, and then y to the 1 is just y. So this second part reduced to 3x squared y. Plus. Okay, I'm just getting back a little bit so she can get part that we missed, that we'd already done.
How did you get to 3?
Because 3 factorial over 1 factorial, 2 factorial. 3 factorial, can you see right here?
Yes.
3 is 3 times 2 times 1, right?
Mm-hmm.
Down the bottom, I have 1 times, and then 2 factorial is 2 times 1. Cancel, cancel, 3 over 1 is?
Oh, okay. 3.
Remember where we had to cancel stuff out yesterday?
Yeah.
Okay, so we're doing the same concept on this next term. Plus, 3 minus 2 is 1 factorial. So, since I have basically the same thing, these are just in the opposite order, should I get the same number?
Yes.
The 2 factorial is going to cancel out the 2 and 1 up here, and then this is just 1. So I'll still end up with
3.
3. If you don't get that, then you write them out like I did over here. 3 times 2 times 1. This would be 2 times 1. This would be 1. And then you cancel out what you can. All right. Now, for this one, 3 minus 2 is 1, so I'll have x. And then here I had y to the second. Okay? So hopefully you're kind of noticing your x's are descending on their exponents, but the y's are increasing on their exponents. Okay? And then we got one last term, correct?
Yeah.
All right. So what's 3 minus 3?
0.
0. So that part's 0 factorial, which is 1, so it's poof, it's gone. Okay, so if I have 3 factorial over 3 factorial, that cancels out to 1. So it's just like the first term. Will I have 1 in there?
No.
No. And then I'll have x to the 3. What's 3 minus 3?
0.
0. So do I have any x's left?
No.
No. So it's just y to the third. So if you look at your answer, hopefully you kind of see some symmetry there. Okay, these are pretty much the same, except one's the x, one's the y. These are pretty much the same, except your exponents are different on your x and your y. Okay, if you had looked in your book, remember they had that thing called Pascal's triangle with the numbers. Okay, when n was equal to 3, when n was equal to 3 on Pascal's triangle on page 489, your coefficients were 1, 3, 3, and 1. That's what we got, right? 1, 3, 3, and 1 when n was equal to 3. So all of that was just one problem. Yay.
No.
All right. You ready for number 9?
Yeah.
Yeah. It's the last one that's long because number 18, we don't have to do the whole big thing. We just do one little piece of it. Okay. So on this one, what's my A equal to?
X, 2x.
A is equal to 2x, and B equals, the sign stays with it, so it's a
Negative y.
negative y, and then my n is 3. Okay, so we're doing the same basic concept of our big sum going from 0 to 3. And you'll notice I picked ones that only went to 3. Some of them have bigger exponents, but I was trying to keep it where it was at least a little bit shorter, but you still kind of got the idea of how to do it. Okay, so when I go to write my sum using my formula up here, it's going to be basically the same as what I started on this one. I have 3 factorial over r factorial, 3 minus r factorial, and then my A was 2x, so I'll have times 2x to the 3 minus r, and then I'll have negative y to the r. And you'll notice I put parentheses just to make sure I keep that negative with my y, which that's why I chose to do this one, because it did have the negative on it. Okay? So that's our general formula that we're going to be plugging in. So like I said, if you want to, you can put parentheses around the 2x as well to make sure you keep 2 with x, whatever works for you. Okay, but that's our general formula. Now we have to take this whole big thing and we got to expand it, work it out. Okay, so are y'all ready for this? No?
Yeah.
Okay. Now, what I want you to understand is the factorial part going to end up being basically the same thing as what we did on number 1. Is this part right here going to be the same as what we did on number 1?
Yes.
Yes, because it's the same numbers, right? We're going from 0 up to 3. So I'll do r is 0, r is 1, r is 2, r is 3. So that factorial part is going to work out to be the exact same. So my coefficients are going to start off to be the same. I know this whole factorial part was equal to 1. That was my first number, right?
Yeah.
This whole factorial part was 3. Then I had this one was 3, and then this one was 1. It follows that Pascal's triangle thing. When n is 3, your coefficients are 1, 3, 3, 1. Okay, so the factorial part is 1, 3, 3, 1. What's different though on this one is because this had a coefficient in it too. So we're still gonna have to do a little bit of work. But do we need to bother to do this part again?
No.
No, we're not gonna do all that part again. We already did it. So when we go to do this, the first one's gonna be 1, okay, because we found out this part's 1, right? Times, we have 2x to the 3 minus 0, because we do when r is 0 first, and negative y to the 0. So I'm plugging, I've got the 1, my coefficient, remember from Pascal's triangle, 1, 3, 3, 1. So I have 1, and then I have my a to the n minus r, and my b to the r. The first one, it has r as 0. My second one, I let r be equal to what?
1.
1. We go in order. My coefficient, that number up front is going to be a 3 times 2x to the 3 minus 1 and negative y. Ooh, that was ugly. Negative y to the 1. Okay. Then I let r be 2. So I have 3 still. Remember, this part still was equal to 3. So I have 3, and then 2x to the 3 minus 2, negative y to the 2. And then my last one has a 1, and then 2x to the 3 minus 3, and negative y to the 3. So I'll let r be 0, r be 1, r be 2. Okay, I sound like I'm in Star Wars there for a second, sorry. RB2 and RB3. Okay, I'm not trying to say R2D2 or anything, but that's what it sounds like. Okay, R is 0, R is 1, R is 2, and R was 3. Okay, and now we just simplify it. So 3 minus 0 is
3.
3. Anything, oh, my marker, I left my cap off too long. All right. 3 minus 0 is 3. Anything to the 0 power is just 1, so I don't have to mess with that. I won't have a y. Remember, did we have a y term on the first one here?
No.
No. Okay, so this is 2x to the 3rd power. So that means 2x times 2x times 2x. So 2 times 2 times 2 is
8.
8. So it will be 8x cubed for my first term. Because that times the 1 is still just going to be the 8x cubed. I see that. This one, 3 minus 2 is 2. So here I have 2x times 2x. 2x times 2x is 4x squared. Everybody agree with that? 2 times 2 is 4. X times x is x squared. Yes, no? You should see heads going this way. Okay, what is 3 times 4?
12.
12 times what kind of, this is going to make it a what type of 12?
Negative 12.
A negative. So instead of a plus, this one's going to have a minus 12. Or you could have plus a negative, but they usually just write it as a minus. X squared and the 1y. Remember, you always have x cubed, then x squared y, and we're going to the next one. Here, what's 3 minus 2?
1.
1. So anything to the first power is just itself. So we just multiply this together. 3 times 2 is 6, right?
Mm-hmm.
6 times a negative y is going to make it a
Negative 6.
negative 6x and then y squared. Oh, wait, is that right? That ain't right. You know, let me do that. Because this is a negative that's being squared. A negative times a negative is positive. Sorry, so that one's plus. So when you have a negative on here like this, your sign should end up being alternating. Positive term, negative term, positive term. So this one should end up being a
Negative term.
okay. Here, 3 minus 3 is 0. Anything to the 0 power is 1. So I have 1 times negative 3 to the 3rd power. Negative times a negative is positive times a 3rd negative. So it's negative, like I said, y cubed. So when you have a coefficient on one of your terms, it doesn't straight follow the Pascal's triangle as far as your coefficients in your answer, but you still use those coefficients in the problem because this part, the combination part, is still going to simplify to the same thing, those numbers that I had on Pascal's triangle. So instead of having to do all this combination part every time, where should you look? Pascal's
Triangle.
triangle, okay? But like I said, we don't do a whole lot of these because they're long. All right, so everybody's got number 1 and number 9. See, they were long. Took up like a whole half a board. Look at that. All right. You ready for number 18? It's the last one.
Yay.
All right, so number 18, on it doesn't want the whole expansion. It just wants the 8th term. So we're not doing all of that mess for the whole thing. We're only doing the 8th term. So since we're doing the 8th term, that means our R is going to be
8.
what number? We have to figure that out. In our first term, R was equal to what?
0.
0. So to find R, what you do is you take this. Hey, I feel like I'm going to cough and it's not coming. You take that and you subtract 1 because your first term was 0. Wait a minute, which one am I doing?
We're 18.
Yeah. So our first term is 0. So you have to take whatever term you're looking for and subtract 1. So my R is actually going to be 7. The 8th term is when R is equal to 7. Okay, so instead of doing the whole big thing, you're just doing basically the sum part when R is equal to 7 and N is 10. But you're only doing it for that one thing. So you're not having to add them all together. Okay, you're just doing the one. So remember, N is what?
10.
10. R was 7. And then our A was 9 to the N minus R. And then our B was X to the R. And so all we have to do is we just simplify that 1 and then we're done. We don't have to do the whole big thing. Okay, so the way this works, what is 10 minus 7?
3.
3. So remember like what we did yesterday? If you didn't know how to do the factorials or you didn't have that factorial button or the combination button, remember 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, I would have 7 times 6 times 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1. Okay? If you had to write it all out, that's what it would look like. Now, hopefully you should see all of this part cancels out all that part there. From 7 down cancels out with the 7 factorial on the bottom. Then I'll look and see if there's something else I can cancel. Okay? 2 goes into 8 how many times?
4,
4. 3 goes into 9 how many times?
3,
3. So I have 10 times 3 times 4 left. So 10 times 3 times 4 is going to be
120.
120. And that's times 9 to the 3rd power. So 9 times 9 times 9.
729.
And then x to the 7th. So I multiply those two numbers together. 120 times 729. So the 8th term of this binomial expansion is that right there. You didn't have to do all the other part, you just had to find that one term. Okay? And the main thing for like when you have the test over chapter 10, I'm not going to have a whole lot of the binomial thing on there. Like I'll have one where you just make sure like it basically followed Pascal's triangle with coefficients. Or I'll have one, but I mean I'll put it like where you're like picking the correct formula for the binomial theorem or that kind of stuff. Okay, I'm not going to have you have to work this big long mess out. Okay, because some of y'all panic enough on tests anyway. Now, up here at the top, I have kind of a review of the 3 formulas that we did yesterday. Okay, we have factorial, which means you have that number times the number before it, times the number before it, all the way down to 1. So if this was 5, 5 minus 1 is 4, 5 minus 2 is 3, so it's 5 times 4 times 3 times 2 times 1. You count down for factorial. For permutation, the formula is this. For combination, it has the extra r factorial in the denominator. Now remember, which one of these does order matter, permutation or combination?
Permutation.
Permutation, order matters. No order for combination, okay? Permutation, order matters, combination does not. Remember I told you think combination is just a collection. You're just getting them all together. It doesn't matter who got there first. Permutation, you're lining them up. You're putting them in place. Permutation, place. Combination, just a collection. Okay. These problems here are the ones that at the end of class yesterday, you were supposed to go back and finish solving.
Yay.
Some of you may have, some of you may not. I hope you did, because when I call your name, if you can't tell me an answer, then it won't look very good for you, will it?
No.
Good. So let's start with you, Nellie, who plays with her hair the whole time we're in class. What is number 11? That's the first one you had to do.
Got it wrong.
How do you know you got it wrong?
Because it doesn't make sense to me.
Well, what is it? How does it not make sense? Mm-hmm. 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 All right, let's try. Somebody want to help for number 11?
Oh, I know. Pick me. Pick me.
Okay, pick you, pick you. What'd you get?
I got 336.
336. Okay. Did anybody try number 21 other than Micah? Really? Did you try it?
Miss, I thought you said we had to do 43 to 52.
I said you had to do these, and answer 43 and 52 were the only two of those you had to work out. We set up all the word problems, but 43 and 52 are the ones I drew an arrow to for you to solve. So I'm saying, I guess you did 43?
Mm-mm.
Huh? You said 43 through 52 is what we had to do, so did you do 43?
Mm-mm. I only did 52 because that's the only one I understand.
What'd you get for 52?
I don't know how to explain it, but I did it.
Just tell me the answer. What's the answer?
It's wrong. I got it wrong, miss. But I know how to start it off. But then I got like troubled with it.
Okay. Yo, class is supposed to be over in like 4 minutes. Okay? I'm supposed to go through. Who did we lose? Did we lose somebody? All right. I'm supposed to go through and try to work all these out. So you have these, because remember, what are you supposed to be doing today over that section?
Quiz?
A quiz, yeah. But if you didn't even try these, all right. Okay. Number 21 was the permutation of 14 and 5. So permutation is this formula. So on the top, I would have 14 factorial over 14 minus 5 factorial. 14 minus 5 is 9.
9.
So I would have 14 factorial over 9 factorial. So that means from 9 down on this one would cancel out. So I would be left with 14, 13, 12, 11, and 10. Because from 9 on down is going to cancel out because that's also in the bottom. So that is what you multiply together to get your answer for 21. When it is a permutation, that's the formula used. When it's combination, like 29 and 35, your formula is a little bit different. Number 29, you had 10 factorial over, what is that, a 5? 5 factorial, 10 minus 5 factorial. Okay? When it's a combination, it has the extra factorial in the front. Now, 10 minus 5 is 5. So I have 10 factorial over 5 factorial, 5 factorial. So 10 times 9 times 8 times 7 times 6, because that part will cancel out the 5, 4, 3, 2, 1. Okay? I get what I'm saying there. This one, 5 factorial, is 5, 4, 3, 2, 1. That'll cancel out the 5, 4, 3, 2, 1 that's on the top. On the bottom, though, I still have this other 5 factorial. So I still have a 5, a 4, a 3, a 2, and a 1. Then when we did those, we looked for things that we could still cancel out to make it smaller numbers to multiply. Okay? So I'm looking I know that 2 times 3 will get rid of the 6 in the top. So I can get rid of that. I know 4 will go into the 8 twice, and 5 will go into the 10 twice. So I got rid of everything in the bottom except 1. Does it matter if you divide by 1?
No.
In the top, I have 2 times 9 times 2 times 7. That's what's left. 2 times 9 times 2 times 7 is what's left. So I multiply that together, and you should have got my markers. 252. If it's permutation, it's the first formula. If it's combination, it's the second formula. Okay, for number 43, we set it up. We said it was a permutation because you're doing officers, so they're in a place, in an order. So since it was a permutation, there were 55 members total, and they were picking 3 officers. So for 43, I'm going to scoot it, I'm going to put it over here. For 43, I would have 55 factorial on the top and 55 minus 3 factorial on the bottom. Okay? Now, 55 minus 3 is 52. So that means from 52 down is on the bottom. So that's going to cancel from 52 down on the top. So the only thing that's going to be left to multiply on the top is 55, 54, and 53. But remember, we said when we did the permutations, you usually ended up with a lot larger number. So if I take 55 times 54 times 53, I get 157,410 ways that they could pick the officers for whatever club it was. Okay. Now on 52, they were choosing the security questions. We said order didn't matter. There were 10 possible questions to choose from, and they were only using 3. So it was a combination. So I had, this is 52. I had 10 factorial on the top, 3 factorial, and then 10 minus 3 factorial on the bottom. 10 minus 3 is 7. So that means from 7 down, 7, 6, 5, 4, 3, 2, 1, that part would cancel out from the top. So on the top, I would have left 10 times 9 times 8, because from 7 down was gone. On the bottom, I still have 3 factorial, 3 times 2 times 1. I try to simplify what I can. 2 goes into 8 4 times. 3 goes into 9 3 times. So I have 10 times 3 times 4. There's 120 ways that they could pick the combinations of security questions. That was from some of them that you were supposed to have tried to done. But apparently y'all didn't. Except Mike. Thank you, Mike. All right, so on your quiz, if I say it's the way to select individuals in any order, which one is that? Permutation or combination?
Combination.
Combination. If it says in any order, that means order doesn't matter. It's a combination. If I say I want them in order, then it's a permutation. Okay. Factorial is represented by what symbol?
Exclamation point.
An exclamation point. Okay. Remember this right here, when it's written like this, that stands for permutation. This stands for
Combination.
combination, okay? Then you have some problems where it's just working out the factorials, okay? So it's simply going to give you a problem like 4 factorial and 2 factorial. So basically that means you take, when two things are right next to each other, it means multiplication. So you have 4 times 3 times 2 times 1. That's that part. And then the other part will be 2 times 1. And you just multiply all that together and get the answer. 4 times 3 is 12, times 2 is 24, times 1 is 24, times 2 is 48, times 1 is 48. So you just work it out. You just multiply them out. So should everybody be able to handle solving factorial? Multiply it out. Okay. Then you have some where you're actually working out the permutation and combination, which if you've got your notes, you got your formulas, you plug the numbers in and you work it out just like all these we just did together up here where we were finishing those. Okay. Now remember, we did have a couple of questions that it wasn't doing this. Like if I wanted to do the PIN number for my debit card, do I do all this or do I just multiply how many numbers I have to pick from on each one?
Multiply how many numbers?
Multiply the numbers. If I was doing a combination of something and I could use any of the numbers from 0 to 9, how many choices do I have for each place? 10. So I would have 10 times 10 times 10. That would be the number of possible combinations for my security code, my combination. Okay? So you do have one question that's like that. But all the rest are permutations or combinations. Okay? If it talks about order, it's a permutation. If there's no order, it doesn't matter. They can be picked anyway. It's a combination. So please, 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 please do not forget to log in and take your quiz. It is quiz number 34. That sound right? Yes. Quiz number 34. And I think I have it on there till like 8 or 9 o'clock tonight. Okay? So that should be plenty of time for you all to get it done. So quiz 34, do not forget to take it. I think we've about got everybody caught up on all their quizzes, so we should be good with that, okay? And then tomorrow we'll be reviewing the whole chapter so you can take your big test over chapter 10. All right? So with these that I just went over again, do you think you can halfway do your quiz? Please?
Yeah.
I hope so. All right. And I'll see you all tomorrow at 1. Do your quiz.